So this is Inequalities Day 4. Yesterday we added and subtracted to solve inequalities. Today we are multiplying and dividing. All right, so on number 1 it says 3x is less than or equal to 9. 3x is less than or equal to 9. You need to copy this problem down onto a blank sheet of paper and solve the inequality just like you would solve an equation and graph your solution. All right, so go ahead and do number 1. So I need to divide by 3 both sides. X is less than or equal to 3. 3 numbers on my number line. What is 1 less than 3? 2. What's 1 more than 3? 4. And open or close dot? Closed. And arrow going left or right? Okay. All right, next one. Go ahead and do number 2. So on number 2, we divided both sides by 2 to get m is less than negative 3. Open dot on negative 3, arrow going left. All right, what do you see about number 3 that is different from numbers 1 and 2? The variables on the right side, which we talked yesterday about the fact that that's kind of like reading something backwards. Okay, so we don't want to read it backwards if we don't have to. So what could we do? So we're reading it frontwards or forwards or however you say it. Yes, flip it. But do you see how the inequality is open towards the variable? Do you see that? It's open. Okay, it needs to be open towards the variable when you flip it. All right, and now I can solve for t. You say, well, Miss Kinder, I don't really need to do that. I know I just need to divide both sides. Well, when we get to negatives on the next section, you'll see why this can be really helpful to you. I would strongly encourage you to rewrite it. All right, what do you do to both sides to solve? Divide by 6. T is greater than negative 3. T is greater than negative 3. Okay, and then you graph it. So open dot and arrow going to the right. All right, go ahead and do number 4. Go ahead and do number 4. Again, I want you to rewrite it so you're not reading backwards, and then solve it. So did you rewrite it? 8p is greater than or equal to 40. Okay. Then what do you do to both sides? Divide by 8. P is greater than or equal to 5. Close dot on the 5. Arrow going to the right. Arrow going to the right. Okay, number 5. What do you see that's different about number 5? It's a fraction. A fraction is connected to the variable. But what operation does it mean when it's a fraction? Division. It means division. What's the opposite of division? Multiplication. And another thing that could be helpful is to remember that what is understood in front of the b? 1. A 1 is understood in front of the b. And then what if a 1 is understood in front of the b, what could I do to get essentially 1/3 to cancel down to 1 to get the b by itself? Ooh, I like it. She even remembered the word. Reciprocal, all right? To get a fraction to cancel out, not to 0, but to reduce down to 1, I multiply it by the reciprocal. So I'm done, right? B is greater than or equal to negative 1. That's my answer? No, because what I do to one side, I heard it. What I do to one side, I have to do to the other side. Okay? Greater than or equal to negative 3. Okay? And plot it on your number line. All right, go ahead and work on number 6. All right, we're going to check number 6 together tomorrow. It's technically a part of the problems I want you to do on your own. And just remember, when you multiply, your answer is going to be a decimal. That's okay. Just still put it on your number line, open or close dot, and we'll graph it that way. Okay, so I'll give you a minute to get started on number 6. All right, let's go ahead and skip over to number 7. Okay, that's down in the next section. All right, number 7 looks like it's about the same, type of problem, right? Negative 5j is less than or equal to 10. That's a pretty easy or pretty simple inequality to solve, right? Well, what would I need to do to both sides to solve that?
Divide by negative 5.
Divide by negative 5. Okay, so Something, though, happens when a negative number is connected to the variable by multiplication or division. This has nothing to do with addition and subtraction. When a negative is connected to the variable, I must reverse my inequality, okay, to solve. So 10 divided by negative 5 is still negative 2. But instead of it being less than or equal to, it's now greater than or equal to. I have to do this in order to make my solutions work in the original inequality. Okay? You guys remember what we talked about yesterday about what does the solution mean? What does this statement mean? You guys remember when I said that? What does this mean about the solutions to the inequality?
That they're not equal.
You know, that all the numbers have to be what? Greater than or equal to negative 2. So give me a number that's greater than negative 2. Any number. Negative 1. Could I even say 0 to make it real easy? Okay, so by switching the inequality, look what it does. What happens if you plug in 0 here? What's negative 5 times 0?
0.
And it is true that 0 is less than 10. If you hadn't switched the inequality, that wouldn't have been true. Okay? So when a negative number is connected to the variable, you must reverse your inequality. Okay, so based on that, I want you to work on numbers 8, 9, 10, 11, and 12. Okay? Now 10, 11, and 12, that's part of your homework problems too. Okay? So we're kind of knocking out homework and at the same time reviewing these together. All right, so yes, we are going to graph these solutions. It should have been a closed dot, arrow going to the right. Okay, so now let's look at is everybody done with number 8? Okay, you guys are doing really well. So on number 8, what do I need to do to both sides? Makai? Divide by negative 4. So t is greater than, I'm sorry. Why did I switch it?
Because
It's too negative.
No. Why did I switch the inequality? Because there was a negative number connected to t. If 4 had been negative over on the other side, doesn't affect the inequality. But because the negative is connected to t, I have to switch my inequality so now t is less than or equal to negative 1. Okay, and then I can graph it. All right, number 9 gets tricky. Why do you think I say that about number 9? Why do you think I say that? Because the variable's on the right side, so it's essentially backwards. And then you had to divide by a negative, so then you have to switch your variable again. All right, so that's why I said in the first section, it's a really good idea. It's a really good idea to go ahead and write it in the correct order and then go ahead and solve it. So try number 9. Number 9, negative 7y is less than negative 14. What I did was I went ahead and rewrote it as I was copying it down. Okay, so I just did that so I don't have to write it twice. That's totally fine if you want to do that too. So now, what do I need to do to solve?
divide by negative 7.
Yes, divide both sides by negative 7. And because I had to divide by a negative to get that variable by itself, I need to switch my inequality. And now it's greater than, what's negative 14 divided by negative 7?
7 and
2. Okay? So what does this mean? This means that any number greater than 2 will make the inequality true. Give me a number greater than 2. 3. What's negative 7 times 3? Negative 21. Is negative 21 less than negative 14? Yes, it is. It's negative.
Oh, yeah.
So it goes farther from 0. Okay, so that's what we're saying here. Any number, there's not just one solution. Any number greater than 2 will make the inequality true. And then you go ahead and graph it. All right, so your homework tonight is going to be 10, 11, 12, 15, 16, 17. 6 problems for homework. We have plenty of time still to get these problems done in class today.